The instructions in 8085 microprocessor can be grouped into this 7 different types of instructions. At the first, we have this data transfer instructions, which have 13 different types of instructions. And from these 13 different types of instructions, uh, we can generate 83 opcodes. And about opcodes, operands, and how machine codes are generated, we will cover it in uh, next video. And we have this arithmetic, logical, stack, branch, IO, and interrupt instructions, right? But in this video, we will cover only data transfer instructions, right? So, what are data transfer instructions? So, by the name itself, we know that in data transfer instruction, there must be some transfer data between uh, something called uh, a destination and a source, right? So this destination can be of a register or a memory location, right? So, and this source can be of register, memory location, or even an immediate data, right? So in this data transfer instructions, uh, one thing we have to understand is that uh, no data flags are affected with this data transfer instructions, which means that after this data transfer kind of instructions, no flags will be altered, right? Uh, these flags will be covered in like different chapters, different videos afterwards. So let's look at the first kind of instructions, which is of the form MVI R, D8. So what does this mean? And if you look at the mnemonics, right? If you look at the mnemonics carefully, it gives informations, right? What kind of instruction is it? So we can look at this instruction first. MVI R, D8. So what does this mean? What does this mnemonics means? This means move immediate data, right? And this is the source, and this is the destination. So what does this mean? This D8 data uh, will be loaded to this register. So let's take an example. So MVI V comma uh, A7. So let's take an example. So what does this instruction do? So after this instruction has been executed, what happens that in the register B, in the register V, this A7 data, A7 is in hexadecimal. So if we convert this hexadecimal into binary, this A can be converted into 1010, and 7 can be converted into 0111. So this data will be loaded to this register. Great. So let's see. Okay. MBI V comma A7 H. And after the end of every program, we have to write HLT, right? And one thing we have to remember is that if your data or if your opcode is uh, beginning with some alphabetical number from A to F. We have to begin the number with a 0, right? So let's see. So this program is supposed to load this data A7 to the register B. Let's see. Now this V has the data 0 0. So let's run the program. So after the program, what we have seen is that this B register is loaded with A7 data, right? So this is how this instruction works. Okay, so let's go to the second instruction. The second instruction is of type MOV R1, R2, right? So what does this instruction do? So in this instruction MOV, so for example, let's take an example. MOV V, say E. So this E is the source register and this V is the destination register, and the content from this source register will be loaded to this destination register, right? But the content of this source register will be intact after the program, right? So let's see how it goes. Okay, we can use this data MVI E, comma. Okay, let's use these two registers B and E, and we are loaded B with A7 data, and we are loading E with some data like say 25H. So now we have two registers. We have two registers, this V and this E, right? This V is loaded with A7, and this E is loaded with 25. And okay, at the third instruction, okay, at the third instructions, let's do our instructions. MOV MOV B, E, MOV D, not D, it should be B, E. So what does this do? We are loading a V with 0A, A7, and E with 25, and what we are going to do is the content of E is loaded into the location of B, right? And after the instructions, after the program has been executed, the content of E will be intact. Only the content of B will be altered. Okay, let's see. Okay, to see this program carefully, we can run the program step by step. We can debug. Okay, let's first clear the registers. Okay, we first clear the registers, and then let's debug it, right? So what do we expect from the first instructions? The first instructions, we are loading V register with A7, right? So let's see. Okay, after this instructions, this V is loaded with A7, and at the second instructions we are loading E with 25 25. This E is loaded with 25, and at the third instructions, we are loading B with the content of E, which means that this VA7, the content of B, which is A7, will be replaced with the content of E, which is 25 to 5, but the content of E will be intact. Okay, let's see. Okay, as we see from this, the content of B is converted into to 5, which is the content of E, but the content of E is intact. Okay. Okay, I think you, you must have understood this second instructions. Okay, let's look at the third instruction again. So the third instruction is of type MOV R, M. Okay, this R can be of any resistor. Any resistor means general purpose resistors, right? Which may be A, V, C, D, E, H, and L. And we have another term called M. Okay, and I think we have no resistors called M. And then what is M? And it has a special meaning. So in our program, if we have M, what we have to do is that we have to look at the resistor pair H and L, right? Whenever we have M in our instructions, what we have to do is we have to look at the resistor pair HL, and this HL pair will must have some contents. So for example, the content of HL pair is 1 2 3 4, right? And then what happens is that this content of HL pair, right, this 1 2 3 4 is the memory location from which the data has to be extracted or data has to be loaded, right? So let's take an example. Let's take an example that MOV B, M. So what does this instruction do? From the memory location which is pointed by HL pair. So this HL pair has 1 2 3 4 as the data, and what we have to do is that we have to look at the memory location whose address is 1 2 3 4, and the content of this memory location is what is to be loaded to your register, to your given register, right? So in our program, if we execute this program, what happens is that the content of this memory location 1 2 3 4 will be loaded to our register B, right? And in the fourth instructions also, if we understand this third instruction, this fourth instruction is just the opposite, right? So what does this do? The content of the register which is provided in instructions will be loaded to the memory location which is pointed by HL pair. So if you understand this third instructions, I think you could understand this for instruction is just the opposite, right? And the simulation of this third and fourth instructions will be done later, because this instructions or the simulations of these instructions require other instructions which will be covered in the next instructions. So let's look at the fifth instructions, LXI RP comma D16. So if we break down this mnemonics, what we can see is that it has L, X, and I. So what is L? L means Lord. So it's written here also. It's Lord. And this X means extended. Right? Extended pair. Extended pair of what? Extended pair of resistors. And I means immediate data. Right? Lord, extended pair, immediate data. And this RP means resistor pair. Right? So if we break down this mnemonics, okay, we have two terms called load and the store. Right? What does load means? Load means we are loading some data to the accumulator from some locations, which may be register or memory locations or whatever, right? Load means loading to the accumulator, and store means from the accumulator to some memory locations or some register, right? So in these instructions, in this instruction, okay, in this instruction, we're mentioning this register pair, right? So this 16-bit data will not be stored, will not be loaded to the accumulator, but to the register pair, which is given in the instructions, right? Say, for example, in this instructions LXI V D16, or instead of D16 we can give some instructions, or not instructions, some data, right? Like 1 2 3 4, right? So if we have these instructions, right? Okay, let me erase this. Okay, let's take an example of LXI B comma 1 2 3 4 H. So what this instruction does is that so this data is of 16-bit, right? 16-bit, and since this mnemonic says X or extended pair, instead of P we will take V she pair, right? Right. We will take register pair, and this 16-bit 1 2 3 4, right? The 16-bit data will be broken down into 2 bytes, right? This upper bytes will be loaded to this upper register, and this lower byte will be loaded to this lower register, right? Understood? So let's see how it goes. Okay. So let's take an example. LXI for register pair, we can take any register pair, either BC or DE or HL. So let's take D for DE, and for the 16-bit data we can take 3, 4, 5, 6, and it should be followed by kites. To sort it, it's a hexadecimal. And then let's first clear the registers. Okay, and what we expect from this instruction is that this upper byte 3, 4 will be loaded to the register D, and lower byte, which is 5, 6, will be loaded to E register. Okay, let's see. Right, this 3, 4 is loaded to D, and this 5, 6 is loaded to E. Right. Okay, and the next instruction is of type MBI comma D8. Okay, and this instruction is the same as the first instructions, MBI R comma D8, and the only difference is that instead of registers it takes M. So what is M? M is the memory location which is pointed by the register pair HL, right? So this D8 this 8-bit data will be transferred or will be loaded to a memory location which is pointed by HL pair, right? Okay, this kind of instructions which have M will be simulated at the last, right? Okay, let's first look at this instructions, at this next instructions, LDA A16. So what is this instruction say? Load accumulator, right? Let's take an example. LDA, say 3, 4, 5, 6, right? So what it says is that load accumulator, right? Load accumulator, not with this data. This is not the data, right? This is of 16-bit, right? This is of 16-bit, and accumulator is of 8-bit. So this 16-bit cannot be loaded to accumulator. So this is not the data which is to be loaded, but this is the address, right? This is the address of the memory location from which the content of that memory location will be loaded to the accumulator. So for example, we have this accumulator, right? And we have a memory stack. We have memory stacks which addresses starts from 0, 0, 0, 0, H to FF, FF, right? So between this 0, 0, 0, 0 and FF, FF, we must have some locations with addresses 3, 4, 5, 6, right? And the content of this memory location, which is of 8-bit, right? This content will be loaded to the accumulator, right? To the accumulator. So let's see how this instruction works. Okay. LDA, let's say 1 2 3 4 H. Okay. Since we have not loaded anything to these memory locations, so the content must be 0. Um, and I think for this also we need some other instructions which we will discuss later. So let's give a letter. Okay, and let's uh, move to the next instructions, which is STA A16, and this is also the same. Like if you understand these instructions, you can understand this instruction also, which is just the opposite. So STA means store A. Store A means from the A, or the content of A will be loaded to the memory location which is given in these instructions. Great. So I think it will be understood if you understand the previous instruction. The next instructions is of type XCHG. XCHG means exchange, and exchange between what? Exchange between the contents of HL with that of DE. Right. We have say we have DE, and let's say this DE contains 1 2 3 4, right? And we have HL pair. This HL pair contains 6 7 8 9. So after these instructions XCHG, the content of this the contents of this register pairs will be exchanged, which means that this content of D, which is 1 2, will be exchanged with this 6 7, and the content of this E 3 4 will be exchanged with this register 8 9. And this instructions doesn't have any opcode, and we call this kind of instructions as implied instructions. Implied in the sense that the user is supposed to understand what this instruction is going to do, even without operand. Great. Okay. Okay. Let's see. Okay. Let's see how this instruction works. So let's first load this HL pair LXI. Let's first load the pair. Wait, the pair with some 16-bit data. So for example, 1 2 3 4, and then HL pair with some data 6 7 8 9. So what we do is that we have loaded the E pair, the E register pair with 1 2 3 4, and HL pair with 6 7 8 9, and then we are doing exchange operations X C H G, right? So to look at the instructions, more clearly, we can debug these instructions, right? So in the first instructions, we are loading the pair with 16-bit data 1 2 3 4. So this is loaded with 1 2 3 4, and in the second instructions, we are loading a HL pair with 6 7 8 9. Yes, DE with 1 2 3 4 and HL with 6 7 8 9. At the third instructions, XCHG or exchange, this the content of these two register pairs will be exchanged together. Great. Let's see. Great. So as we can see, the content of the is exchanged with HL pair. Great. So this is how this exchange instructions takes place. Okay. The next instruction is of type LDAX RP. So let's break down this mnemonics. LD means load, A means accumulator, X means extended register pair. So what does this say? Load accumulator, right? Load accumulator from memory pointed by extended register pair, right? So we have accumulator and we have a register pair which is given in the instructions. So for example, let's take an example, LDAX B. So what does this say? Since it has X, we will take this register as register pair. We'll take as BC, right? So instead of HL pair, this BC register pair will act as a pointer, right? Will act as a pointer, which means that the content of this BC register pair, right, is the address of the memory location from which the data has to be transferred or data has to be loaded into the accumulator. So for example, this VC contains 5 6 7 8 as the data. Okay, if this is the case, what we have to do is that we will go to the memory address called 5 6 7 8, and from that memory address the content is extracted and is loaded to the accumulator. Great. And this is how this instruction has to do. Great. Okay, and this next instruction is also the same, right? In the sense that it's just the opposite, which this instruction says STAX, store accumulator and extended register pair. So what this instruction do is that we have A, right, and we have a register pair. So if the let's take an example, STAX D. So if this is the instructions, what happens is that the content of this memory the content of this accumulator, right, is loaded to a memory location which is pointed by this DE pair, right? Right. The content of the DE pair is the location of the memory address to which the data from the accumulator has to be loaded, right? Okay, let's see how this instructions works. Okay. Okay, let's see. Okay. Um, okay, let's first load our accumulator with some data. MBI A with some data like mm, 3 3A, let's say. Okay, A is loaded with some 8-bit data, 3A. Okay, and okay, um let's use DE pair. For this, we have to load this DE pair with some 16-bit data, right? So we have to use another instructions, LXI D, comma, say 2, 2, 5, 8, 4, right? Okay. In the second instructions, we are loading DE pair with this 16-bit data 2584, right? And this 2584 will be the address of the memory location to which uh, the content of the accumulator will be loaded, right? Okay, STAX D. Okay, let's see how this instruction works. Okay, let's debug the program so that we understand step by step in the instructions. Okay, in the first instructions, we are loading accumulator with some data 3A. Great. As you can see, the accumulator is loaded with 3A. And in the second instructions, we are loading DE pair with 16-bit data 2584. So D will be loaded with 25 and E will be loaded with 84. Right. Okay. And in the third instruction, what we have to do, what this instruction do is that this the content of this accumulator 3A will be loaded or will be copied to a memory location which is pointed by this register pair D. So in short, this program does is that this 3A, which is the content of accumulator, will be copied and stored to a memory location which addresses 2584. Right, in the address 2584, in the memory address 2584, this 3A data, which is the content of accumulator, will be is going to be loaded. Right, let's see. Okay, for this we have to look at the memory locations, right? So at the memory locations 2584, so what is the content? This 3A. Yeah, right. If you look at this memory locations 2584 contains the data 3A, which is the content of the register, which is the content of the accumulator. Right, understood. Okay. And the last instructions is LHLD. Right, this is not the last, this is last but one. LHLD is 16. So this is load HL pair using direct location, right? So what this instruction is that in the instructions we will have a 16-bit address, right? And say so let's take an example that okay, let's remove this first. Let's take an example. L H L D, say 1 2 3 4. So this instruction does is that okay, this HL pair will be loaded, right? This HL pair will be loaded from the locations given in the instructions, right? Okay, let me tell you again. What this instruction does is that from the memory location which is given in the instructions, the data from that memory locations will be loaded to the HL pair. How? This is the L, this is H, right? So the address which is given is 1234, and it has the 8-bit data, right? So this the 8-bit data, which is the content of this memory locations, will be loaded to the L register, and the content of the next address, which is 1235, right? The content of this memory locations will be loaded to the H register, right? And this last instruction, HLD, is just the opposite of the previous instructions. So what does this do? What it does is that to the memory address which is given in the instruction, so for example this is A16, which is provided in the instructions. So the content of L register will be copied to this address, and the content of H register will be copied to the next instruction, which is A16 plus 1, right? This is what this instruction is going to do, right?